Guys, welcome back. This is Danny here. We're gonna talk about hoisting today. And even though I talked about hoisting in my previous videos, though I went through depth about just what happens in the compiling phase versus runtime phase in almost every single video, because that concept is basically what you need to understand, and everything else is gonna make sense. Really, what happens at the compile time and what happens at the runtime, you understand what happens there. I feel like you can understand. You could just from there you could add bricks on top of everything. Obviously, I spend my time learning Kyle Simpson's You Don't Know JavaScript, and I'm beginner myself with JavaScript. I come from Ruby background, but I from there on, whatever I read and stuff like that makes a lot of sense, just because I knew that concept. So here we go. We're gonna talk about hoisting. You might want to check out all the videos that I've made in the past before how what the compile time happens, even though I'm gonna explain it again. So let's dive in. Uh, in the compiling phase, at the beginning of all things, when you press enter, the computer, right, the program, the compiler tries to read all the codes and then turn it into a from the source code, turn it into a binary code in which computer can understand, and it's going to run back again, and that's what we call runtime phase, and then execute the codes. We're going to talk about the compiling phase, and here we go. So well, the job of the compiler is to pick out all the variable and function declarations and then store it in the appropriate scope. And so here we go. And it looks at the console.log. It's not a variable declaration or the function declaration. How do we know? Variable declarations start with var at the front, and function declarations start the statement with function. All right, so console.log a. All right, nope, it's not a variable declaration. No, no, no. And here it is. That's a variable declarations, right? So we're gonna write what happens. Okay. It talks to the global scope and goes, hey, global scope, we have a variable declaration called a. We have an identifier a, and it's a variable declaration. We're going to store it into the global scope, and global scopes, go ahead, bring it over. So we declare a variable a declaration, and we store it into the global scope. That's what happens. And that's what we call hoisting right here. From here, it gets declared, goes up, and then if this is global scope right here that contains all of these gets stored. Right? That's hoisting right there. And next line, variable b. Again, remember, we do not assign the b to it because that's not the job of compiling phase. That's the runtime phase. In the compiling phase, we only worry about variable and function declarations. Now, it looks at the next line. Variable b equals 2, right? Gets declared, talks to the global scope and puts it in, and it gets hosted up and gets sucked into the global scope. I see global scope as like this invisible, like a black hole right here. Like it just gets sucked into. All right, next line. Console.log. These are just not variable declarations, so we're gonna skip it as a whole, and we're gonna skip it, and we're gonna leave that. And my friend is calling me, but yeah, later on. Anyways, so that happens, right? And here's very important thing to understand. That's when the compiling phase is done. Runtime, couple of seconds later, my runtime happens. Runtime executes. However, by the time runtime happens, all the variable declarations, right, have been already declared. So var goes away, right? What's left at the compiling time now is this. All the variable declarations have been hoisted, got stored into the scope, and what's left of the codes are these, right? That's basically it. And this is when the JavaScript communicates again with the scope. So scope is the primary focus of compiling phase and the runtime phase because everything is done by communicating. Compiling phase, we declare, store it. And in the runtime phase, we ask for it, get it back, and then we run it. So this right happens. We do console.log.a, right? This is RHS, right hand side reference, because we're trying to use this declaration identifier. So we talk to the global scope and goes, hey, do you have a identifier called a? And then it goes, global scope goes, yes, we have a variable declaration called a that we have constructed, but it has no value. But we get it anyway and we execute. And because there's no value, it's undefined. And then we go to the next line, right? And then we ask the same thing. We have a same communication with the scope. Hey, global scope that we are currently in right now. So that context would change depending on what scope you're in. But we're currently in global scope right now. So we go, hey, do you have this identifier called B? And he goes, yes, we do. And again, there's no value, so we get it back and it's undefined. And undefined is an object of value itself that stands for no value. All right, next we have A equals B, right? Assignment. This is an assignment. So we first thing we do is left to right. We ask for the identifier called A to the global scope. It gives it back to us. Now we assign it to B. However, we ask for identifier called B again to the global scope, and they go, yes, we have a variable declaration called B. However, there's no value, so really we're assigning A to undefined value. And then we ask for the global scope. Hey, do you have a variable declaration called B again, or identifier called B? He gives it back to us, and then we assign value 2. And the next time we console.log, we ask for B again to the global scope, and then it gives it back to us, and we execute it. And because we assigned 2 to it before, we could now have a value. And A, we asked for A. However, remember we assigned it to a B when it didn't exist, so it's undefined. Now this is kind of, some people might think that, hey, even if A holds B, right, and B we changed it to 2, then shouldn't A become 2? No, because when we asked for B, right, and then we actually executed it, undefined came out. So it's no longer B anymore. A doesn't hold B anymore. It holds undefined now. So when we execute the A, we execute the undefined. So that's example 1. I hope that made sense. And number 2, here we go. All right, we're going to start back from the beginning again. It's the compiling phase. So here's what happens. All right, so we look at this whole thing in the compiling phase, and we do the variable declarations and function declarations first. And we look at variable A, and then we create it, right? So we go, hey, global scope, we have a variable declaration called A. We're gonna store it into the global scope because we're currently in global scope right now, and global scope goes, yes, sure, why not, and it creates it, and it gets hoisted up to the global scope and gets stored, right? And we're gonna take out the VAR now. Why? Because we just created a variable declaration and stored it into the scope. So what's left is actually the assignment that we're gonna run at the runtime, right? Next line, variable C. We declare variable C. We talked to communicate with the scope we're currently in right now, which is global scope. Put it back in, and then variable C gets hoisted up and gets stored into the global scope. What's left is equals D. A and C we skip. You know why? Because it's not a variable declaration, function declaration, and that is not the job of a compiler or the compiling phase. That's the job of runtime. So we just leave it. Now here's the fun part. We look at the function declaration, function B, right? And what happens when this is a function declaration? Because the statement starts with the keyword called function, right? If let's say if this was an if, for example, then this is immediately invoked function expression, which makes it no more function declaration because it has this parentheses at the front. It must start with a function declaration, function keyword to make it a function declaration. And every time function declaration is called, we talk to the global scope, hey, we have a function declaration called function B with the identifier called B. We're going to have to store it into this global scope. And not only we store this whole function object into an identifier called B, we recursively go back in and execute the codes inside, because every time a scope is created, every time a function object is created, remember, function is the only unit of scope in JavaScript. Every time a function scope is created, you recursively go back in and do the hoisting of variable declarations. Even if this function it gets created at the runtime, which we're going to show down here, hoisting happens regardless. So hoisting happens regardless. Hoisting is the default behavior that just comes along in the right of when the function is declared. So right here we go in, we do the hoisting of variable declaration, function declaration, it doesn't exist. This is not of any variable declaration or function declaration, so we just leave it and function is created and it gets hoisted up to the global scope. Where under here? No, because when you hoist a function, it takes precedence. It goes before declarations of variables, and function is hoisted to the top. This is how it is. Function is the first class citizen right here in JavaScript, and yeah, that's it. And then what happens is we look at the next line, and this is a variable declaration, but it's not a function declaration because the statement starts out with the var, right? This is a function expression, meaning function is a value, right? It's getting assigned, and it's in a position of a value. So we create a variable declaration, vard, and then we get hoisted all the way back up here, and we put it right there. And because we declared the variable declaration, what's left is this line, right? And that is it. That is finished version of compiling phase. Now we're gonna enter the runtime phase. Remember, this is stored into the global scope. But so what we're actually dealing with at runtime is this. So we look at this and we go, all right, we have to assign A to B, right? We look at global scope. Do you have, because we're currently in global scope right now, do you have a variable declaration called A, right? And it gives it back to us. So we get it. And we ask for an identifier called B, right? Do you have an identifier called B? It's a function declaration. And it goes, yes, we do. It gives back the function. We get it and we execute it, right, with these parentheses. So we recursively go back into the function object, and then we execute this, return C. Now we ask the current scope that we are in right now, and we're currently in this function. So it goes, hey, scope of B, function B, do you have this RHS, right hand side reference identifier called C? No, it doesn't. So we go outside. That's what we mean by fishing. Excuse me. I have to drink some water here. So we go outside, and there's a global scope, and we ask the global scope, hey, we're looking for this identifier called C. We're going fishing right now. Do you have it? And then the global scope goes, yes, we have this variable declaration with the identifier named C. Gives it back to us. However, it does not have any value, right? So return C is gonna be return undefined. So A is gonna hold undefined. That's what's gonna happen. And then we go to the next line. So we ask the global scope again. Hey, global scope, we have a we're looking for this variable declaration called C identifier. Do you have it? And it goes, yes, we do. We get it. Now we could assign a value to it. We're gonna look for right hand side this time. By the way, LHS, left hand side, when we're looking for LHS, LHS and RHS is terms that JavaScript uses in order to communicate with scope engine. And depending on if you're looking for left hand side or the right hand side, how the global scope or the scope respond to it, or the global scope respond to it is different. If you're looking for right hand side and ultimately it doesn't exist, then it's gonna be like, hey, we don't have that identifier, we don't have the variable declarations, and it's gonna throw an error. But if you're looking for left hand side, right here, like C, variable declaration or identifier, with the purpose of assigning a value, no matter what, JavaScript is gonna help you to assign a value to it, because it's not really a big deal. You're just trying to create a variable to assign a variable to it. So even if you never declared it, it's gonna ultimately go fishing outside the bubbles and bubbles and bubbles until it reaches global scope and goes, hey, do you have it? And it's gonna be like, no, but I just created it for you, and bam, you're gonna have it. That's the difference between left hand side and right hand side, which I cover in my past videos. Okay, so here we go. C equals D, right? So we as for D, variable declaration D, which it has, the global scope does. We're looking for right hand side now, intent to use, but it has undefined value. So we're right here is variable D. It's got declared. However, the assignment of a function object did not happen yet, so it's undefined. You can't really execute a function that doesn't exist yet, right? So we now go to the next line. This is we look for left hand side, no right hand side, because we're intending to use, or just think of it as if it's not left hand side, which is looking for an identifier to assign a value to it, then it has to be right hand side. And right hand side identifier is usually when you're trying to use it, execute it, right? And we're looking for A, and scope gives back the A, which we assigned it to B, and it returns C. And by the time it got to C, it had no value, so undefined. And same with C, undefined. We already covered this. All right, here we go. Next line. Now this is my favorite part. All right, so we talk to global scope again and go, hey, do you have a variable declaration called D? Yes, we do. We have it stored. It gives it back to us. Now we can assign a value to it. It's left-hand side that we just asked for, left-hand side identifier reference that we asked for, and it gave it back to us. Now we could assign a value to it, right? And then what do we know? We have a function object as a value, as an expression. You know, it's a function that is a value now. So we assign this function expression to this variable declaration that we just received, reference that we have received. And because it's a function, we have to create the function object, the function scope. And I talked about earlier, the default behavior that comes along with when you're creating a function object or function scope is hoisting. And its hoisting involves all the variable declarations and function declarations and storing and hoisting up to that scope that we're currently constructing right now. And that is the function scope. So we go in, we look at the variable declarations and function declarations. Does it exist? And no, it doesn't. But if it did, it would do it right now. So like variable d hello, you know, like that, you know. If that actually did exist, then it will be stored, you know, like right now, the variable declarations will be created and get stored into the scope. That is the default behavior. I hope you got that. But it doesn't exist right now. So it's done with it. Now, right, the function object is done being created. Now, some people will be like, hey, what happened to return B, right? But we're just assigning a value to it, right? We're just assigning a value to it. So we just assign the function object, right? And when you're assigning a value, all you're doing is constructing a function scope. And when you're constructing a function scope, it's like kind of like a compile phase. You're just declaring variable and function declarations inside of that scope only. But let's say we have something called D here, right? Then it's gonna talk to the global scope and then go, hey, do you have a what do you call this identifier called D? It's gonna give back to us this function that object that we just created, and we're gonna execute it. We go back in because we're actually executing the codes now. It has returned B, which we would have to execute, right? And it would have to look for the scope that it's currently in function, right? And go, do you have B? No, it doesn't. Then it goes fishing outside, and then you look at it, talks to the global scope. It's right hand side B, and then you will get it, and then return C. You will go outside and look for C again, and this chain of go fishing would happen. So whenever you have a function expression, what you need to know is that variable declarations happens first, and then the actual assigning the function happens at the compiling phase. Therefore, constructing this object, function object, happens at the runtime phase. And when you're just assigning a value to it, only the variable declarations and function declarations inside of that constructed function will be happening, will be done, will be taking place only. And when that is done, and when you actually execute it, then you go back in and execute the codes, right? And essentially, if you look at this is not a declaration, right? It's a right-hand side or left-hand side reference, right, to the global scope, or the scope that it is in right now, function. This is the right-hand side because we're looking for an identifier called B, and we're trying to execute it. So this is not a left-hand side. We're not looking for left-hand side identifier. If we're trying to assign a value to it, then it's a left-hand side. But we're trying to use it, so it's a right-hand side reference identifier. So really just think of it as at runtime, anything that is right-hand side or left-hand side reference, then we're gonna try to do that at the runtime, or it happens at runtime. But if we're looking for variable declarations or function declarations, that takes place in the compiling phase, or when the function is created. When a function is created, object is created, hoisting comes as a default action, and hoisting involves declaring all the functions and variable declarations. Okay, guys, I hope that was really helpful. Yeah, I hope I covered everything. If you need to understand how all of these things work, I talked about all these things in my previous videos, and this is very important because this is my blog that I'm creating because I don't like writing, and English is my second language, and I don't do good with writing. So this is my journey with Kyle Simpson's You Don't Know JavaScript, and it's a great book. I learned tons, and this is just something that if you like, you should definitely purchase the book and save yourself a month of studying, and yeah, that's it. All right, guys.